Hello guys, welcome back to my channel. So today we'll discuss on top 50 composite material interview questions and answers related to the industry uh, uh, aligned questions. So, so let's start. So the first question is, what is composite material? If anybody works on composite projects or composite related job, so they may ask a few questions on composite. So first they'll ask, what is composite? Composite is a material made of two or more distinct constant, which is fiber plus matrix, to achieve property not possible with either alone. So why are we using composite instead of metals? It's because it has very high specific stiffness and strength, corrosion resistance, and design flexibility. And what is the role of fiber and matrix? The fiber actually carries the load, whereas matrix transfers the load, protects the fiber, and provides the toughness. Next question is the difference between isotropic and anisotropic materials. Composites are anisotropic. Property depends on the direction. So, what are the common composite fibers? One is glass fiber, carbon fiber, and aramid, or we also call it as Kevlar. So what is thermoset and thermoplastic composites? Thermoset is it is non-remeltable and it has very good thermal stability. In thermoplastic, it is recyclable, tough, and fast processing. So what is fiber volume fraction? The fraction of fibers in the composite directly controls the stiffness and the strength. Why our void content is critical? There are voids during manufacturing. There is some voids will form. So why the void content is important? Because the voids reduces the strength, fatigue life, and the damage tolerance. So next question is, what is lamina? What we call lamina? It's a single ply fiber in one direction. And laminate is a stack of lamina with a different orientations. So why ply orientation matters? Because as I said, this is a directional dependent property. So it controls the stiffness, strength, and the load path. And typically the fiber orientation, what is a typical fiber orientation in the industries? The typical orientation is 0 plus or minus 45 and 90 degree. This is also called quasi-isotropic type of laminates. So this is a common type of stacking sequence they commonly use in the industries. What is balanced and symmetric laminate? Balanced in the sense like plus or minus theta plies are paired, so that is called balanced. Symmetric, it is a plies are actually mirrored about the mid planes. That's those are called symmetric type of laminates. Why avoiding bending twisting couplings? Because if you have bending twisting couplings, it causes unwanted deformation under load. This is a famous common questions they ask in the interview. What is ABD matrix? It's related to the midplane force or the moment to the strains or the curvature. So why quasi-isotropic laminate is used? Because it actually provides almost isotropic type of behavior in plane behavior. So that's why in aerospace industries they use quasi-isotropic lamps. And what is a common composite manufacturing process? There are so many manufacturing techniques. The common one is hand lathe and autoclave, RTM, resin transfer molding, filament binding, and automatic fiber placement, the AFP. Autoclave versus out of autoclave. So autoclaves usually we use for high quality type of specimens and which is very expensive. Whereas out of autoclave like hand layers and all, it's cost effective and it actually leads to a higher void risk. So what is pre-preg? It's a pre-impregnated fibers with controlled resin content. And what are the common defects we observed in the composite? So one is void, fiber waviness, uh, delamination and resistive changes. Effect of fiber waviness. What is the effect of fiber waviness? It reduces the compressive strength drastically. What is cure cycle? It controls the temperature and pressure profile for the resin curing. So the next is why the moisture absorption is an issue. It's because it reduces the glass transition temperature and the strength. What is drapability? It's the ability of the fiber to conform to the complex shapes. So next is why thermoplastic gaining interest? Because it has so high toughness, impact resistant, and it's recycle. Mostly it's a recyclability. And what are the, this is also a very famous question, what are the failure modes in the composites? So one is fiber breakage, matrix cracking, delamination, these are debonding. These are some of the failure modes we observed in the composite materials. So what is the difference between first play failure and ultimate failure? Uh, the first play failure doesn't mean it's a structural failure because it has a lot of fibers. So once one fiber fails, it actually takes other fiber can take that load. So we can't say that first play failure is a failure. It's not a structural failure. Why delamination is dangerous? Because it reduces the load transfer and the buckling strength. And this is also a very common question. So, what are the common composite failure criteria? So, there are so many failure criteria they used in aerospace. So, the common failure criteria is Sahil, Saiwu, Hasin, and there are PERC. So many criteria are there. So, I just mentioned some two, three. If you answer some two, three failure criteria, then the interviewer will be happy. So, which failure criteria is more realistic? Hasin, generally people use Hasin because it separates the fiber and matrix failure. So, the next question is how does the composite fatigue differs from metal? Uh, this is also very interesting question. So, it's a progressive damage instead of single crack growth. So what is barely visible impact damage? So we call it as BVID. So it means it's a hidden internal damage caused by low energy impact. Like in composite, actually, when we are conducting any impact test, low energy impact, we can't see the damage inside the fiber or inside the composite laminate. So when we do some NDT inspections, then we can able to see the impact damage. So that we called as barely visible impact damage. So the next question is why compression after impact is critical. So composite loses most strength in compression, compression post impact. So that we call it as we do some residual strength test. So that's in compression we do some impact, then do some compression study, see what is the residual strength or residual tensile strength, etc. So how is delamination model in FE? There are two methods. One is cohesive zone models uh, and VCCT. So what is the damage tolerance in composite? Damage tolerance is the ability to sustain the damage without catastrophic failure. And this is also a very common question. They ask in the interview, what is rule of mixture? So rule of mixture is nothing but it's the estimation of composite property from the constraints from the fiber and the matrix properties. So what is the limitation of the rule of mixture? Uh, So the limitation in the sense it does not capture the damage or the manufacturing defects. Shell versus solid modeling for composite, which we usually use. For thin laminates, we use shell, and for thick laminates, solid elements, solid modeling. And for delamination studies and all, we use solid modelings, the composite. And what is ply-by-ply versus SMAD model? The ply-by-ply is accurate, but computationally it's very expensive. So why peak interlaminar stress is tricky? Because it's highly mesh dependent. So it's because of that it is bit tricky. So the next question is, how do you validate composite FK? So correlation with coupon, element, and subcomponent test. Uh, so this is how we can validate. So what are knockdown factors? So it's a margin applied to account for defects and uncertainty. How do joints differs in composites? Like we have bolted joints, so that causes the stress concentration. The bonded joints need careful designing. So why composites are not sensitive? Because the load redistribution is limited compared to metals. So the next question is the environmental effect on composite. So like moisture, temperature. So due to this effect, actually the composite properties it reduces. So this is the effect on composite. So why a certification of composite is costly? Because so the composite is heavily depends on testings. So that's why it's certification of composite is costly. Typical industries uses composites. Where are the application of using composite? One is in aerospace, automotive, wind energy, and marine. So, what is the biggest mistake in composite design? The biggest mistake is we sometimes we treat composite like an isotropic metals. So that's the biggest mistake. We should never treat as isotropic. The behavior is entirely different from the isotropic. So this is actually orthotropic. It's a directional property dependent. So the next is future trend in composite. So the answer is they use ceramic matrix composite, automated manufacturing, thermoplastics. So this is some of the future trends. The final question is one line industry philosophy. In composite, manufacturing is a part of design. Manufacturing, we have to, like, it depends on the properties, depends on how we lay up the fibers, stacking sequence, and type of matrix, what is the volume fraction of fiber and matrix. So all these things it actually matters during manufacturing. So this is a part of design, this is not entirely a different thing. So that's some questions, interview questions. These are some of the basic questions they may ask. I did explain it briefly because I mean elaborately. So it's just one answers is enough. If you want very detailed answers, just please comment below. I'll just in the next slides or in the next presentation, I'll explain some of the questions or whichever you want. Okay, thank you so much.